Okay, we'll speak about BGP flow specification. I'll speak for, I think, the first 8 slides or so, and then we'll get to the good stuff, which is actual deployment experience and what this actually looks like in a real network. So first, the problem. You know, today providers have some limited means for mitigating large-scale DDoS attacks. In fact, when Danny and I did the survey earlier this year and the year before, the most common way that providers mitigate attacks is by black holing. And while this is very effective to stop the attack traversing the provider's network, it's perhaps less effective for actually helping the customer's website, SQL servers, or other things that are under attack. And it turns out that not all customers are clueless. Many of them are, but not quite all. And there's been a growing push from many customers for providers to offer commercial mitigation services. These services include things like FlowSpec, which we'll speak about today. It also includes things like inline firewalls, things like Cisco Guard, Arbor's TMS, other types of intelligent filtering devices. But in general, before we come to FlowSpec and come to intelligent filtering devices, really the options include anything from just BGP destination black holing to ACLs, all of which have fairly serious implications on customer traffic or fairly difficult to operationally deploy. So what is BGP flow specification? Well, the basic idea is that we've got this thing called BGP, and we've got lots of experience stuffing all the stuff into BGP that may or may not really belong. 2547 comes to mind. But this great distributed protocol, one of the most widely distributed protocols on the planet, what if we could stick some other stuff in BGP, like firewall rules, use the BGP basic authentication mechanisms, distribution mechanisms, and dynamically pass firewall rules around on the network, not only intra-provider, but perhaps even if we could do this between providers and filter closer to the source of attacks. So that's the high level, what is BGP flow specification. We'll jump into a few details. So what is a flow specification? Well, it's just another address family, yet another opaque address family that BGP just treats independently of the V4 or V6 tables. That the flow specification includes some predefined communities that go along with the flow specification. The communities include the basic, what you'd expect, discard, rate limit, but there's also some really nifty capabilities which we'll speak about shortly, including redirection based on things matching this firewall rule. And basically, the BGP flow specification provides a way within BGP to encode matches that include things ranging from source destination prefix to ports to the ICMP code, packet size, DSCP, TTL. And an example of at least an ASCII example of a filter below is, match TCP these ports and for this /24. So significantly more flexibility, of course, beyond what we used to have, which was black hole all traffic to this /24. The flow specification model basically uses something similar to BGP. That is, we've got BGP already deployed, and it's more of making sure that the flow specification is congruent with IPv4 routing. And by congruent, I mean that it's a little bit different using next hop within flow specification. It really is making sure that the flow specification is from where we expect it to be from, or that it's poking a hole in existing advertisement. Of course, as we'll speak later on, there are ways to set your own policy. You can, in fact, if you've got devices in your network announcing flow specification, turn off these policies and just trust the device is sending the right thing. And we'll speak about that shortly. But basically, it follows many of the same rules as we know and love with IPv4 and has all of the issues associated with that as well, of course. So why flow specification? What are the benefits? The benefits are you can pass around filters with BGP's ease of deployment and management. And we have experience with BGP. To some degree of solve, we have solved the trust authentication mechanisms, modulo, even earlier talks today. But it exists today is probably the strongest argument. And it provides a way of leveraging increasingly some of the ASIC filtering capabilities in routers. What are the drawbacks to BGP flow specification, trying to provide both sides of the coin? Well, when there are criticisms about BGP flow spec, the biggest criticism basically comes down to that it uses BGP. And as such, has all the faults and foibles of BGP, including, yes, BGP lacks security modulo, SBGP and other proposals, that there's no application level acknowledgement, that is, you can't actually query a router, or there's no predefined way to understand what is matched and what filters have been accepted. It, of course, only works where you have BGP. Should we be overloading BGP with something, yet another, is an open question, more of a religious argument than perhaps a technical one. And I think a few other sort of standard issues. Flow specification is an ITF draft standard. I think it is it expired, or is it? It's about to be renewed, but it's an ITF draft standard. It's implemented, at least one major router vendor has implemented it, and as of Juno 7.2, but 7.5 and others, it's there. I'm aware of at least 3 U.S. and European providers who are in various stages of rolling out the service, including Time Warner Telecom speaking today. Several other vendors have announced integration, for example, including Arbor. And I won't speak about today, but Cisco has a complementary TIDP proposal, and happy to speak about that, or Barry can if he's here, if you want more details. With that said, I'm going to turn over the talk to Raul from Time Warner Telecom.
So, I'm Raul Lozano. I'm going to start first with a slide of Time Warner. We're based in Littleton, Colorado. We became separate entity from Time Warner Incorporated. Just so you guys know, we're not Time Warner Cable or Time Warner Telecom by itself. National IP backbone, we have a transport and switched service provider, 44 markets, 23 states. Again, managed services, managed VoIP services. We have a Juniper backbone and a Cisco Power Metro. Here's a beautiful picture of our network. So what are those problems that we're facing? Some already were mentioned by Craig. Basically, our large customers are getting attacked. And we kind of have an ad hoc type of response where the customer kind of calls into the NOC. We investigate the problem, and then we generate some type of mitigation technique in the devices. Recently, we just allowed the customer to advertise their own /32 with specific flow community to black hole themselves, but the problem that's only on the aggregation point to the customer, so that still carries the traffic all the way to the egress point to the customer, so that hurts the network. So these attacks are generally creating congestion in our network, so they're not only intended to our customers, they affect the network, they also affect other services like VoIP, something very important now, and it can also isolate some of our POP sites. Again, increment the cost of operation takes time to mitigate. These are ad hoc responses, as I said, so it depends on how fast you can respond to these mitigation techniques. Other observations we have seen is DDoS attacks are coming from organized type of crime, botnets type of that, and also they're coming from amateur type of attacks. So it's difficult to really understand from where we're getting those. Generally, we get botnets. There's kind of a little bit more organized there. Anomaly that we find, but that's what we have seen in our network. Again, we have TCP SIM flood attackers who generate small packets per second that create a lot of damage to our services. And again, we have UDP type of fragment attacks that are also generating problems in our network. So other observations we see is that we are seeing some ICMP type of traffic too, trying to generate HPings or whatever. We try to filter that in our network, and we don't see a lot of those ICMP attacks constantly in our network. But we will still protect ourselves by doing some firewall filtering. But they're static, they stay there, so if in the future it comes kind of outdated, we have to go again and update the configurations. Other stuff we have seen, a lot of the traffic and attacks that we have seen are coming from the Asia Pacific area. Difficult to track, difficult to identify just because national NAT gateways. So you see a lot of generation, and you don't know if the source is really that source. Here's a diagram. We use Arbor to display this, where we can have kind of a 2.7 million packets per second. That maximum sustain is not there for a certain period of time. So just demonstrating that we get those attacks and we get those reports into our network. So previous mitigation approaches, again, black holing, sometimes also removing the prefix to the other provider, so that also affects. Well, it's a very good mitigation technique, but it also affects the traffic of the customer. So that's the problem with those type of black holing the destination or removing the prefix out of our peering points. Arbor fingerprinting sharing, we have done that with our providers and tried to show our signatures of attacks and try and share with our other peers. And it's still something that is just starting. Requires a lot of get in contact with our peers and try to generate those fingerprints and understand the attack that we're trying to mitigate. So other mitigation challenges we see in our network is firewalling, filtering, and black holing are kind of insufficient just because it takes time to generate. We have an attack, we have a signature, you have a destination and a source. You try to black hole the destination, you try to put a filter in the device, so it takes time to implement that. So that's one of the things that we're looking for something that is a little bit faster response. Another thing is it terminates the traffic of the customer. So that affects the availability of the customer. And again, constant configuration changes add and remove routes that are black hole routes in the device. So it requires changing configurations and all that. Mitigation challenges, again, it takes from 15 minutes to an hour to mitigate an attack, and it all depends if we identify the attack or we get a call from the customer, we have to identify the filter or the route, try to deploy it into the device, so it takes time. It's not a very fast response again, and I guess a lot of operators will probably experience something similar. I mean, it takes time to do that, and it all depends on the experience of the personnel working on the NOC or working in engineering or security engineering. It takes time. If you have only one security engineer, it will take more time to generate a certain filter, or if you have more, I mean, it depends. It relates all to cost of your group and how much people you have in your team. So mitigation today, we just started doing a deployment of FlowSpec, beta deployment of FlowSpec using a kind of a control deployment on our peers and transits, and I think peers and transits are important where we get all the traffic, but we're trying to do some type of scalable solution where we use BGP community architecture to be very granular in our advertisement. So we advertise FlowSpec to a specific router where we get the anomaly coming from, and we're not affecting the whole network. So by that we're using UNOS 7.4R3 and Arbor 3.5. That's currently our mitigation tools that we're using for FlowSpec. Again, the Security Operations Center will initiate the FlowSpec mitigation using Arbor. And again, as Craig was saying, we're using BGP for propagation of FlowSpec. If you already have BGP, I think it makes sense and you already have the devices that support FlowSpec. I mean, if you already have the architecture for BGP, it's going to kind of facilitate this already if you already have it in your network. So I have here a diagram of the architecture, and I think Craig was able to put some of the configurations available for the audience. I'm not going to go through the configurations of each device and FlowSpec, but here, technically what we have here is Arbor, where the Security Operations Center is monitoring that, pairing with a route reflector, and then the route reflector peers with the peers in transit, but each peer in transit has a specific community. This community, we decided to make it independent for each device, and it's a group of communities that they are basically targeting the role, the geographical position of the router, and if it's a peer, if it's a transit, and how many peers in transit you have on the site. So then all the information is gathered by CFlow data and BGP information from all the other devices in the network. And basically what we have is like this simple attack where we have a source and a destination to that destination port. What happens, that's going to get alarmed in Arbor. So the Security Operations Center will be able to mitigate that using that the technique of FlowSpec, and it's going to pre-populate that information in our mitigation tool. So what happens, it gets mitigated by only advertising to that transit thanks to that community that we already had. And this mitigation that we see there is kind of a very general, and it almost looks like a filter. I'm doing that destination and that port and discard all the traffic, so anybody that is peering in that transit is going to get affected by that FlowSpec filter. So the idea is to be more specific, put a source or put a TCP flag or put a destination port. We already have the destination port, the source port. So the more you put into the FlowSpec advertisement, the more specific you're going to be, and the less of the outage you're going to have for the customer. Again, if I generate another attack, we have that coming from that source and that destination, and the Security Operations Center gets the alarm, decides to mitigate, and it decides to mitigate using the source prefix of /24, and again, that's more specific than the previous advertisement. The problem there is affecting the whole /24, so you probably want to trim that to a /32 at the destination, as the destination port. If it requires a DSCP code or a TCP flag, all that gets identified by our monitoring tool. So FlowSpec allows you to be that specific and advertise that with that specific signature. Experiences with FlowSpec. So this is new technology that we have. Vendors supporting it from monitoring and from routing perspective. So we have our box, and we have found that in our network testing. So again, we have generated like our examples that we have seen that are fixed now, but just stuff that we have found on lab. We have generated multiple destination and source signatures and tried to deploy them to the devices. Well, what happened is instead of mitigating that specific signature, everything got mitigated for that destination and source. So that got fixed. Another thing was as soon as you were deploying FlowSpec to the device was being mapped differently into the router. So if you were mitigating port 80, you were really mitigating port 4000. So that didn't really make sense, right? But things that were kind of discovered during the lab testing and all that. Other limitations that we have seen is reporting, and it's starting to get improved. The devices, the routers report pretty accurately the dynamic filter, because really FlowSpec, it's a dynamic filter that gets installed into the device. The problem is generating like CFlow data or stuff like that. We're trying to work with our vendors to get more in reporting techniques to be able to graph that and have a better tool for our network operators, because that's the main requirement. How do I know that the mitigation it went through? As soon as you mitigate, the traffic is going to stop, but how do you know for how long and all that? So we're trying to get those counters into a better graphical reporting tool. Planning and testing. Again, we did lab testing using traffic generators with certain flows, specific signatures, DSCP codes, TCP flags, to be able to identify that with our tool. And then what we did is mitigated with Arbor. So basically that was our lab testing and our lab deployment. FlowSpec works. We're very impressed with the way it helps to us to do a faster response into the network. So I think the main key here is FlowSpec by itself is kind of a filter. It doesn't really give you the flexibility. It's like a normal static filter. I think the main thing is to have some traffic analyzer in front of it. If you analyze the traffic and you know what you're getting attacked, FlowSpec will make a lot of sense. Again, a controlled deployment. We only started with peers and transit and using the community architecture to make sure that we're going to be able to specifically mitigate where we wanted to mitigate, not trying to deploy flow spec all around the network, because there's no need if it's only coming from a certain entry point. Okay. So I'm going to go through some of the lab environments that we had and some of the stuff that I think very interesting too. We verify what something called route instance and also rate limiting. So flow spec can also help to do that. And in this example, you're going to see that we have, again, the internet and our aggregation and peers and transits, but I have there a VPN called the cleaning VPN, and then I have a device called there the cleaning station or the firewall or router. I mean, in the lab, it was really a router, so, but it can be a cleaning station. And it's advertising a default route to that BRF. So the intention of this is if we get a certain signature or attack or to a certain network device, to be able to use flow spec. In this case, we're using only a router to generate this flow spec advertisement. But what happens is I'm going to generate that signature of the source and destination, but I'm going to attach or tag that with a route instance, and it's really a VRF route target. And what happens is that that router, the peer router, is going to import that traffic into that VRF. Very interesting that since I already have the default route in that VRF, it's going to automatically start diverting the traffic to that device. That device is also participating on a normal IB4 network to another interface. So what happens, he has a default going back to the other network. So what comes out green, clean or whatever. But the idea is that that device can help to be some type of scrubbing tool or a mechanism to clean the certain signature of traffic and all that. For us, it was only a router, but it's open for any other application. Again, another thing was to create the rate limiting, and I thin out the blinds but that's the idea. We can rate limit to the traffic. So other applications, I don't know, probably there's some type of alert or anomaly that we're not sure that we want to mitigate it, or really we want to throttle the traffic because, I don't know, this email or something like that. You can still rate limit that and do some type of scrubbing if it's necessary. So again, I don't want to say what is that box. I just wanted to show more kind of the application that can be there. So what is missing? I think one of the main keys is multi-vendor support. I think I have heard some people interested of deploying flow spec, but you have seen in the previous slides we talk about Junos, and that kind of limits a little bit the deployment of flow spec. I think it's a good idea to have all the vendors starting to participate in this draft. Again, and I'm going to talk because our current vendor, Juniper, but I think if we add more features into the flow spec advertisements, it's going to open to more applications. Right now, it's kind of strict to a certain destination and source prefix, but what if we can do more kind of I'm thinking more of a prefix list, where if you get a botnet from different sources, you can generate the dynamic prefix list where it gets applied to flow spec and have a better mitigation technique. I mean, these are things open that we have kind of think that makes sense, and I think in the same thing as with Arbor, we try to report better on the mitigation techniques. I mean, if you have the mitigation and you if you have the alert and you mitigate that, you would like to also have the report of how long the mitigation is continuing to happen, and then if you want to remove the filter later. Other things too is, do you want to have kind of an automatic type of mitigation? I think automatic makes a lot of people nervous. You don't want to have a device to auto-mitigate your network. But if we start trusting more and these reporting tools get better in their anomaly detection, probably that's going to make sense in the future when network starts growing and growing faster, so bigger, I mean. Another thing I was talking is to have some type of signatures repository where you already have well-known flows that are already kind of going to create some type of worm or DDoS flow. Why not have that already kind of being automatically installed in your device? Again, that's kind of things that we think can happen, but who knows? Probably is crazy talking. Who knows? What is missing again into carrier support? I think why did we allow other peers to advertise FlowSpec? Why it makes sense? Why not our peer that is getting attacked through our connection? Why they don't generate that FlowSpec route and mitigate it in our network? It's open again to questions. What if that creates a lot of outages in our customers, in our peer network, thanks to us? So that's a little bit of a thing, but I mean, it makes sense if we can allow other peers to mitigate in our network and we can do the same to others, that can probably open to a better relationship with them. Again, change specific signature fields on the flow spec, on the flow. Things, if you have a certain alert that is being generated with a certain DSCP code, why not change it to best effort or something like that? So it's things that we think they are valuable for us in the future for continuing to use FlowSpec. Just to talk about recommendations if people are thinking to use FlowSpec network on operators, I think it's to consider right now a single vendor support. If you have this on your peers and transit aggregation, I think makes sense to already deploy it. Another thing is to do a controlled deployment. Use BGP. I know people say why use BGP is kind of not that secure, or depends on how you're going to deploy it. If you're going to use only one route reflector in your network, well, then that's not that secure, right? If the route reflector goes down, you're going to lose all your flow spec mitigation. Another thing is the most important thing, and I'm going to say that flow spec by itself is a normal filtering, dynamic filter. It makes it's very useful for deployment, but you really need to analyze the traffic. I think that's the most important key to make flow spec to make sense in the network. Again, it's a low-cost deployment right now. If you already have the gear, I think it's a good thing you guys start looking at it and try and do lab testing first because it makes sense. And again, I think I can say the response to mitigate is a little bit faster. It still requires engagement of the Security Operations Center. We cannot go and mitigate automatically. We have to really engage sometimes the operator, the customer, whoever owns that network to make sure that we're going to mitigate correctly. But at least we don't have to worry about configurations and creating the filters or the certain configuration or script to deploy it on the network. So I think, again, FlowSpec offers you the granularity, and I think that's a key thing for FlowSpec. It's open for questions.
Hi there, Roland Dobbins, Cisco. I have 3 quick questions for you, if that's okay. The first question is, and I'll just give all 3 questions, you can answer them. The first question is, when you talk about policy like prefix list and things like that, are you thinking about perhaps whitelisting certain types of things from being mitigated and things of that sort? The second question I have for you is, when you talk about automatic response, are you proposing a fully automated system as opposed to operator-assisted automation? And then the third question is, you also raised the possibility of inter-provider communications of mitigation information. Have you held any initial talks with other SPs, and if so, what was the response there? Thank you.
Well, I'm going to answer not the first one. I'm going to answer the two after. First, we have not engaged any of our peers or that to do this type of mitigation. It's only something that we think in the future can probably make sense if everybody starts working with FlowSpec. So I think that answers. I mean, we are only proposing right now that can be the future. That's what I think. It can be helpful, but right now it's not. We don't have engaged anyone. The other one was do automatic mitigation, and I think it's also an idea that we think we already have the data being collected by NetFlow or CFlowD or SFlow, and we start trusting more though that information. Why not possibly try to apply that auto mitigation with using FlowSpec to our devices. But again, we have not really generated anything automatic right now. Everything right now is to operated by person, and it's to engages other groups to make sure that the mitigation is going to be accurate, and we're not going to do some false positive mitigations.
And the other question I had was, you talked about distribute lists.
Let me answer the whitelisting question first. Actually, there are folks that that we've seen that are looking at a point, and what they want to do is apply exclusion policies for things that they might do, like scrubber, guard kind of mitigation, that sort of thing, and so they could forward traffic on that they know to be legitimate and not have to consume resources on some deep packet mitigation device to for those microflows, network transport layer attributes, whatever. So yes is the answer.
Okay, and the other question I had was again about the prefix list. Are you thinking about like whitelisting certain types of things, or what did you mean by the policy and prefix list statement that you said was currently missing today?
I think that's the idea, to kind of to do that, but again, there's only kind of, yes, just a white list, listening that certain anomaly of that, I think that will be, but I still didn't got the question right. You mean the policy apply that, or?
In one of your slides, you said specifically one of the things that you'd like to see in future FlowSpec implementations had to do with policy statements and prefix lists, and I was wondering, what is your application for that? Is it just whitelisting, or do you have other thoughts in that area?
Well, right now it's kind of as the signature of FlowSpec. It's a destination and a source prefix. But what if you get an anomaly coming from a lot of sources? You have to create for each one a specific flow spec. Why not to allow a prefix list that can group all that to be able to do the mitigation? I think that's important, just because you don't want to create a flow spec if you have 10 different sources or different ports. So you kind of want to be able to kind of use or regular expressions or a prefix list to be able to do that, right? So that's something that I think should be very helpful for continuing this. Thank you very much.
Yep. John Christoph. So I think I have more comments than questions, but I'll certainly welcome the feedback I'd like to hear from you about this. The one concern that I've sort of had is not so much that it's BGP and BGP is insecure per se, but that it gets if it's still transitive, if I understand the protocol correctly, that this information gets passed around in the routing tables. And that may be such a big problem. With your example, that seems like a really nice application of FlowSpec, and it seems to fit in perfectly with things like that Arbor does. But passing that around the routing tables, particularly in the public internet routing tables, well, from a research perspective, I certainly have an interest in this. I think it would be really interesting to collect this at route views. I think there'd be some interesting things that you'd get out of that. But it's not that the security of BGP is necessarily a problem, but I guess I'm a little bit concerned about the stability if it's widely deployed. And I'm wondering what sorts of applications you've seen yet between provider, and if there's been any studies to that effect there.
Yeah, I think the way to think of this is much like other NLRI attributes, such as VPN. And today you do it within your own network, and it certainly wouldn't show up in route views, at least I'd hope. And you'd expect the same if you did have bilateral agreements with your peers. So I don't think that this is something that would be a transitive BGP attribute that would make it into route views. I think it's much more akin to what providers today are doing with VPNs and other sorts of non-transitive BGP attributes and address families. Randy?
Randy Bush, IIJ. I'll leave as an imagination to everybody else what I think of more BGP and adding more BGP speakers to my network. And especially when they're speaking in new and strange tongues. But what my real question is, I'd like to see in the relevant literature section of the paper a discussion of the Floyd, Bellivan, et al. Pushback stuff, and where the decision was of what of that to take and what of that not to take, because I think that's critical to what you can do for DDoS mitigation. And since that's 5 years old, and I'm kind of disappointed at its lack of progress, and this is along that vector.
Yes, so I'll comment some on that. For your first comment, actually, the alternative of potentially running another protocol and having to debug that and so forth is kind of the trade-off, and of course that's for the network operator to decide. And then as for the pushback stuff, so this is vendor implemented. I know of 3 implementations of this, and it's actually not an IDR working group document at the moment, if that's what you're asking about that versus pushback.
Stuff never managed to do anything in the IETF like
Right.
most things. Let's forget the Internet
Okay, no,
Vendor
that's
Task
what
Force.
I was wondering.
I just meant the actual, there were actual published papers on that, and I just would like to, I thought that was very well thought out stuff. I'm not saying this is not. All I'm saying is in the literature references section of this, I'd like to understand how the two meet and what's good and what's bad and why this is better. I'm not saying it's worse.
Oh, no.
I'm just saying I'd like to be able to see those more visibly.
Yeah, I think that would be a worthwhile effort to undertake. So.
Any other questions? Thank you very much.